Hello everyone, welcome to our presentation today. My name is Jingqian Laflamme from Pathwise Analytics. We are very excited to take this opportunity to walk through our project findings, proposed solutions, recommendation today with our team. Welcome to CEO, Board of Directors, and someone who listen in. Let's jump in and start our presentation. Let me start with asking you a question. How many of you know what people think when it comes to applying a life insurance policy? According to our research, here is what most Americans think about life insurance application process. It is intimidating. Ask way too many questions. It is mysterious process. Need a urine test, blood test. Long waiting period for results. After this long and painstaking process, some people surprised to find out their application can even be rejected. Customer experience, complicated underwriting process, and prolonged waiting period for issuing a policy. These are all pose a big challenge to insurance company today. That's why we're here to help Prudential overcome these challenges and gain competitive advantage in insurance market. To level set, I'm going to quickly go over with you our company's mission and strategy. Pathwise Analytics leads the strategies that enable enterprise-wide data-driven decision-making through partnership, interpretation, and delivering. Our mission is to build innovative solutions from data that enable enterprise-wide decision-making through science and applying research. We enable and provide real-time, automated reporting and ad hoc data analysis to our customer. Next, let me take you through our meeting agenda for today. We will start with introduction, which gives you high-level overview of our company, project team, and our product services. We will then begin with a summary of a problem we tackle for this project. Under this session, we will go over Prudential's current problem and take you through our finding of root cause of these problems, present you with our solution, project objective, project cost, and the return on investment. From there, we will discuss the data, this including data source, initial thoughts on the data set, our exploratory data analysis process, and then, of course, we will cover data cleaning and transformation. Then we will explain our approach on modeling and analysis. This including our data visualization, discussion on modeling with SAS Enterprise Miner, R, and Python, as well as our analysis and discovery. From there, we are moved into the real reason why we're here today. That is our recommendation to the executive board. We are making our recommendation align with your company's vision and strategy, and ultimately help your company to increase profitability and enhance customer experience. Next, we will also use few minutes to showcase the dashboard and mobile app we developed for this project. Lastly, we will conclude with our next step and closing comments. Now let me take a few minutes to introduce you our company. Pathwise Analytics is an innovative and the industrial leader in data science market. Our motif is to deliver high reliable and analytical solutions through expert use of data. As a service-oriented group, we provide a project-based consulting service to various financial and insurance companies worldwide. Our team consists of management consultant, data scientist, data engineer, and the research that with elite educational and professional backgrounds, providing a wide range of comprehensive solutions. As a team of experts specialized in insurance industry, we have a history of introducing novel and innovative solutions to drive digital transformation with the life insurance industry. Next, I will present you our project team. Jinqian Laflamme, the project manager. She is responsible for delivering overall project. With 22 years of extensive knowledge in financial and insurance industry, she specializes in designing and executing solutions for complex business problems by involving large-scale data warehouse, real-time analytics, and the reporting solution. Should any question arise from the executive team, she will be the main point of contact for this project. Xiaoyi Lucas Liu. Lucas is our machine learning programmer for this project. He will be responsible for pre-model EDA, data transformation, and predictive modeling in machine learning technique. Lucas has more than a decade of knowledge in financial and risk management industry regarding to finance, accounting, and data modeling. Hua Wang. Hua is our senior data scientist. He has wealth of knowledge in predictive modeling as well as business analytics. He has successfully demonstrated his ability in various big data, fintech-related projects through past years. He acts as a data scientist, subject matter expert in this project. Chandra Molly Shara. Chandra is our data visualization developer in Pathwise Analytics. His primary responsibility in this project including designing, coding, and delivering executive summary dashboard, as well as reporting related to templates, tables, and graph. Judy Wu. Judy is our project technical writer and editor for this project. As a writer and editor, Judy has specialized on translating technical results into simple, concise, and meaningful summary. With our high-performance team, we are using an agile approach to manage this project. Agile methodology is highly transparent and collaborative. We partner with our client Prudential to involve in the entire development process. Our project team is looked to the client to specialize what is going into each sprint and review our work product during each review session. This continual iteration reduces the confusion between what the client wants and what our team are going to provide. Let me quickly take you to our company's web page. On the home page, we show a snapshot of our success, our team, and our product and service. Under each subpage, we have full detail of our team. There's a short bio for each team member, as well as our project, and our top client. Prudential Financial is currently our biggest client in our firm. In addition, we also added most recent development of a mobile app, which we will showcase later at our presentation. Let's look at our problem summary. To most American households, buy life insurance is a mysterious process. There's no end in sight. The typical life insurance application takes average of 30 days, primarily due to slow and labor-intensive underwriting process. This process is very complicated and requires customer providing extensive personal and medical information. In one-click shopping world with undemanding everything, the life insurance application process is antiquated. When the underwriting process is slow and the user experience is dated, customers select another carrier or abandon the sale entirely. That's why only 40% of U.S. households own individual life insurance. Prudential needs quicker, less labor-intensive underwriting process for new and existing customers. Our team took a deep dive into the root cause of the problem before making our proposed solution. The root analysis process takes 5 different steps. We went through step 1 of defining the problem, collecting relevant data, identify potential causal factors, and arriving the following root cause of the problem. Prudential's current underwriting process is slow, labor-intensive, and manually managed. The process takes average of 30 days to issue the policy, and they require various paramedical exams. The company collects and share more and more personal data. It becomes harder to efficiently estimate risk level in a reasonable time due to information overload. From there, our team took a close look at the entire application of issuing a policy from start to finish. There are 8 steps in this workflow, and breaking down into 2 main parts: data collection and internal review. It appeared to us the longest process in these 2 parts are medical examination and the underwriting review process. We estimate the overall average underwriting time is 29 days. The fast time in underwriting is 22 days, and the slowest time is 52. As our team fully understands the root cause of this problem, we are very confident by utilizing advanced algorithm underwriting will significantly accelerate our current review process and cut down over cost of issuing a policy, as well as increase customer satisfaction. Here is our proposed solution. Pathwise Analytics propose automated your underwriting process by developing a mortality risk assessment tool. This mortality tool can accurately classify risk using a predictive modeling approach. This tool will significantly speed up the current underwriting process, improve accuracy, and cut down the expense of issuing a policy. The tool could also potentially replace simple underwriting process and leave complex case for manual review. In addition, we create a web-based visualization that enable underwriter, agents, and consumers to easily and transparently interpret risk score. This interactive tool will help to enhance customer service and elevate companies' competitive position. We believe this could be a game change of underwriting in insurance industry. Here is the scope of this project. Pathwise Analytics will develop an advanced risk assessment algorithm to calculate life mortality risk score or risk ranking. We will also create mobile app to calculate risk score in real time. In addition, Executive Dashboard will highlight the details and explanation of the applicant's life mortality risk assessment. Lastly, we will provide a documentation for modeling, data, and method used to develop our final model. This documentation will be served for training potential data analysts to maintain the model going forward. Let me take you through our project costs quickly. The estimated total project cost is $200,000. 54% of this cost is Pathwise Analytics consulting fee. We will also consider hire third party to help us for our model validation process. In addition, 7% of the cost will be our annual maintenance fee for Pathwise Analytics to keep our model current going forward. In previous slide, we share with you the project cost. Here is the return on this investment. The success of Prudential Life business hinges on efficiently and transparently estimating mortality risk to drive profitability and enhance customer experience. Therefore, the risk assessment application we develop will enable Prudential to issue a policy online. We expect this model will cut down the underwriting process from 30 days to 5 days and improve the overall operation efficiency for Prudential by 15% each year. The total cost savings will be around $6 million. We believe our solution is going to put Prudential in competitive advantage in insurance industry. Next, I will hand over our presentation to Lucas, our machine learning programmer, who will deep dive into our exploratory data analysis process.
Thank you, Christine, for introducing each of our team members and had a great problem summary on our project. Now we move to exploratory data analysis EDA section. EDA is very important and critical for model selection and other model-related analysis. From the simplified data dictionary table listed here, there are a total 126 independent variables. If we exclude ID variable, which will not be used in any of the model here, also one dependent variable called response. Response has 8 possible ratings from number 1 to 8. 1 has the lowest risk rating and 8 is the highest. In addition, 124 out of 126 independent variables are anonymized with normalized data. There are 13 continuous variables such as weight, height, age, or BMI. The remaining variables are either categorical or dummy variables. The limitation is that all those data are from kaggle.com. There is no detailed explanation for all those variables. For example, it is tough to understand the difference between medical history 1 to medical history 41. Therefore, the EDA cannot be as good as we expected due to lack of information on each data variable. There are training and testing 70-30 data sets, which has been already split by the Prudential Life Insurance. For EDA, our team decided to combine both training and testing data sets to a complete data set. Next, let's look at the missing data among the complete data sets. You can see the table here, and it is ranked based from the lowest to highest regarding the number of missing data here. The last four data variables, either the missing majority of the data or lack of explanatory power, are decided to be excluded from the modeling. The remaining 9 data variables with missing entries can be imputed by rpart library package. Rpart package will impute data based on standard binary tree approach. After the missing data issue has been solved, we can take a look at several interesting points for the complete data set. At first, let's look at the correlation among those 13 continuous or numeric variables. You can see that all the high correlations have shaded with the blue color here. For example, family history 2 has a correlation of 0.91 with the insurer's age. Family history 2 and family history 4 has a correlation of 0.97. The high correlation among those variables indicate a high serial correlation or multicollinearity issue among these variables. So we're going to pay attention to using one of those variables together. Second, the distribution of those 13 data variables seem odd for many of them, such as product info 4, family history 3, 4, and 5. Only a few of them have bell shape or normally distributed to the data. Our team tried to use a different data transformation approaches, including using logarithm, square root, but cannot make the data distribution as normally as what we expected. Finally, let's look at the risk category distribution on the training data set. From a graph showing here, the high risk categories from 6 to 8 has a very high concentration here. The interesting thing is the middle tier rating, 3 or 4, has lowest concentration. Based on our observation, Prudential's data has non-normal and odd data distribution here, which implies that traditional statistical modeling such as logistic modeling or LDA may not work very well for those data. The whole data set is missing data explanation on many fields such as medical history 1 to 41, medical keyword 1 to 48. Therefore, it's tough to understand the whole data set. Machine learning as well as ensemble method will be a better approach for this classification model project. Next, Shanja will discuss the predictive modeling solution by using SAS Enterprise Miner.
Hi, my name is Chandramouli Sharma. I am the data visualization and predictive modeler for Pathwise Analytics. Today I'm going to explain how we used predictive modeling as a means to an end, which is to find out why the prospects drop out from obtaining a private health insurance, which is the problem statement from our client, who is Prudential Insurance Company. So the goal is to build a parsimonious classification model, that is a model with few variables that explains the most variance in the response. Our goal is to build such a model, and for that we want to first select the predictors that are most powerful, that has the most predictive power, and we select those predictors that minimizes the sums of squares of errors, or those predictors that increases the sequential r squared value of the model. That is how we are going to select these few powerful predictors. So we used SAS Enterprise Miner basically for predictive modeling along with R and Python. And also Angus was used for checking the correlations, such as Spearman's correlations of the predictors with the response, basically trying to understand which of these predictors will show a maximum variance in the response. That is, which predictors explain the maximum amount of variance in the response variable. So this is the list of predictors based on their Spearman's correlation, like we just talked. That is how much of a variance these predictors explain the variance in response. So there are few strong predictors, but because the column names are anonymized, we are unable to make an intuitive understanding of the predictors yet. So after we make our first delivery to the client, we wish to understand more about these predictors, and with that understanding, we'll be able to make a better model or a much informed decision than what we are trying to propose now. So we employed the 70-30 split for the data, that is to use 70% of the data for training and the remaining 30% was used for testing the model. This is done because the model accuracy is always evaluated on the test data. So the transformations were applied on the variables to increase their predictive power. SAS EM has convenient ways of doing it, such as it has options such as best option, which applies a series of transformation on each of these predictor variables and selects the best variable that brings about the most predictive power in the model. And these variables are selected based on the sequential R squared value. Some of the other pre-processing that were done on the variables are optimum binning for interval targets, and we used dummy indicators for class inputs and class targets, and also some of the missing values were treated as levels. We imputed some of the missing values, but few columns which we thought was important were used. The missing values in those columns were treated as the dummy indicators. Well, we built several models such as zero inflated Poisson's ratio, neural net followed by decision tree, that is a neural net decision tree combination, and an ensemble model of the above models. So the accuracy of the models was tested by submitting the model to Kaggle, uh, which is which is where we got our data set. That is one way of assuring that the models that we build are accurate enough based on the testing that the Kaggle is doing. They test on a certain metric which is different from the regular root mean square error. So um, our model stood at the 60th percentile on the leaderboard, which is quite good for us at this point of time. We constantly hope to improve the model accuracy and recalibrate the model, which is a part of the data science, which is completely iterative in nature. In the next few sections of the videos, we're going to see how the kind of plan that we propose to our client on refining and retuning the models or recalibrating the models. And then the table here shows the Kaggle public score. So the neural net followed by decision tree was something that stood at the 60th percentile. So we plan to propose this combination for production use. The reason this fits well for us for the client that we are working for is um, when we make a decision, we are supposed to explain on why we are making a decision. That is, when we take adversarial actions, for example, if we deny or if we intimate a customer that they are not able to get a health insurance for whatever reason, we are able to explain those reasons based on our neural net decision tree combination. So the decision tree will be helping us in interpreting on how neural net is making the decisions. So So our final goal here is to minimize the wait time for the prospects, which is a major factor in prospects dropping out of obtaining a private health insurance. The excessive wait times is due to the lengthy medical tests that the prospects have to go through. So from our the data analysis that we did in the beginning, we saw that there is a certain product that most customers fall under. There are four categories as shown in this pie chart. So our goal here is to keep these values or these sectors as the threshold and look for prospects with attributes that lead them to these four categories. This is how the insurance company will be able to maximize the resource allocation and minimize prospects dropping out of the waiting line. So here the adversarial action for us is to intimate the customer or the prospect of a probable wait time, and periodically reach out to the ones that are far behind the queue to update them of how long it's going to take for them to be addressed, so that way they can make an informed decision whether to continue to stay in the line or to opt out. And we feel that will maximize the chances of turning the prospects into customers. And of course, we're going to use our decision tree to explain the reasons for those wait times if a customer or a prospect questions our decision on treating them the way we want to treat them.
Hi, my name is Hua Wei, and I'm the data scientist on the team. Next, I'm going to talk about the recommendation. So throughout this project, we have developed a couple models, starting from the simple logistic regressions to more complicated models like decision trees, random forest, neural net, GBM, XGBoost. Among all the models, XGBoost was the best performing model, achieving a Kaggle score of 0.66. And after that was neural net. Even though XGBoost was the best performing model, it was also the most complicated one. It's not that easy to explain, as well as other models we listed here as in the black box category. In the insurance industry is a highly regulated industry. Your model not only needs to be well performed, but more importantly, it needs to be explainable. So the regulators know that you're not, for example, discriminating against certain populations. So it's important to explain your model well. For this reason, we recommend the decision tree and the logistic regression for their simple yet interpretable, uh, and they're clear enough to show the regulators. So in summary, I want to show that our recommendations as as the follow. First, we want to always try linear models. They're simple, but they can be very powerful, so that they're a very good starting point and never underestimate it. And if a linear model is good enough, you don't need more complex models because they're hard to explain. And even though they're good in training, they may not be really practical in reality. So pick models in balance of performance and compliance. Don't go too complicated. And refit the models periodically as the business and our customers evolve over time. It's a very dynamic marketplace. The models can be as good as its data because as the market change, as the customers change, we need more features to model the customers, especially in the big data era. Uh, we have new technologies like Internet of Things, health devices like Fitbit, Apple Watch. They're capable of capturing customers' data. Of course, those need to be highly regulated and restricted. But in the future, they may be available to us and can totally change our modeling process. So as the technologies change, we will definitely need to keep up with that. So that's our recommendation. And also lastly, definitely take full advantage of our powerful real-time mobile app and our dashboard. And talking about the dashboard, I will give a quick demo next. So the demo of the dashboard, basically, the dashboard has four parts, using four different simple yet powerful and widely used visualizations. The bar chart on the upper left, the box plot on the left, lower left, and the scatter plot on the upper right, and the pie chart on the lower right. So next, I'm going to give a real demo that showing the dashboard hosted on our Tableau server. Okay, so here is our dashboard, and it's hosted on the Tableau server on the cloud. The good thing of that is it will not be impacted by any potential interruptions. Basically, the executives and the business stakeholders have access to the dashboard 24/7 without any interruptions, and they always have the latest data. As soon as the data is updated in our database, the Tableau server will retrieve the latest data and reflect it on the dashboard. So here you can see that we have four different visualizations. So this one is the bar chart showing the Pareto chart showing the cumulative distribution across. It's basically a pretty uh, steady growth up until this point here. We have a 95% of the customers fall below 0.72 of the insurance age. And also we have a box plot here showing the distribution of different risk groups by different variables. Here is dynamic. We can change BMI to employment info to show that how it changes for each of the variable. And the business users can drill down to the insights they want to see and accordingly. And here we have the scatter plot showing the height and weight by different risk group, as we can choose, for example, response A is the safest group of customers. Here we can see the cluster distribution of 1 and A, 1 being the riskiest group, are quite different. And as we navigate along, we can see different patterns demonstrated by different risk groups of customers in terms of their height and weight. And we also added a simple linear prediction line here for each of the group. And lastly, we have this total response group shown in a pie chart. It's basically showing the proportion of customers fall under each of the risk levels. Now we see that the number 8, which is the safest group, make up the large majority at 32%, which is a good thing. We want majority of a customer to be under this bucket to be the safest. And as the business changes, maybe this group of customers will shrink. That means that that's not a good sign for the business. Then we're getting more riskier customers. And so we may need to fine tune our models to be more strict so that we don't lose business on very risky people. And on the other hand, if this group of customers expand, like for example, from 32% to 50%, that's a really good sign that are attracting high quality, safe customers, and that we can probably loosen up our models a little bit to provide more products to our customers. So with this report, we can keep track of how our customer and how the business evolve over time, and basically make data-driven decisions based on these for our executive and business stakeholders. Thank you. Next, I will turn to Christine to demo the mobile app.
Thank you, Hua, for showing us the great design of interactive dashboard. Next, Chandra and I will take you through our mobile app development. We attempt utilizing Wix code that is a new product development from Wix, adds more advanced functionality to Wix editor. This enables us to quickly and easily create a data-driven, web-ready application tool. We created front-end user input screen with selection of a handful of strong predictors such as product, BNI, age, gender to calculate the risk score. These inputs connect to the relevant column of our database collection feature in Wix. The model takes these user input and calculates mortality score in real time. The score is then translated into 8 different risk classes. This web-based visualization tool enables underwriters, agents, and consumers to easily and transparently interpret risk score. Next, I take you through how this app actually works. Here I'm showing you, this is our life mortality risk assessment tool. We have a choice of a product, and you can choose whether the weight of the applicant and the height, whether they are male or female, and their ages to calculate the risk. The risk score is changed based on the selection. So in this situation, for example, the whole life product weight at 180, around 6 feet, more than 6 feet, male, at age 40 has the mortality score of 24, which equivalent translated into a standard non-smoker risk class. Now I give to Chandra. He is going to show you his mobile development in Android Studio.
So we built an Android app which takes some of the important predictors and makes a decision, that is whether they fall into a certain category. They've been grouped into 8 different classes, and our app is going to tell which class the prospect is going to fall under. So the app development was done in 2 phases. The first phase is to develop a machine learning model in TensorFlow here. We selected TensorFlow because TensorFlow has a mobile version called TensorFlow Lite, which is having some convenient ways of transporting the predictive model into an Android development environment, which is Android Studio in our case. So the first part is to build a model in TensorFlow, and the next part was the development of the Android app itself, the front end and the back end, which is done in XML and Java respectively. So for the sake of simplicity, we selected top 9 predictors based on Spearman's correlation as inputs to the app. So the current app design takes 2 hard-coded values for each of these 9 predictors. And if the user checks in the box for one of the predictors, then it uses one value. If the box is not checked, then it uses an alternative value. So that is the current design. Of course, we want to make these checkboxes into text fields so that the user can input any value within the range, and they should be able to get the classification of the prospect. That is going to be an enhancement that we plan to do as we continue to work on this project. So, like I mentioned, TensorFlow's mobile version called TensorFlow Lite is used. One of the key aspects of TensorFlow Lite is it produces a file called the protobuf file, which is a file that contains all the frozen variables that one would need to score. So that is the reason why we selected TensorFlow Lite. So the TensorFlow has a very convenient way of freezing the model parameters in a graph definition file, and a graph definition file is another form of protobuf file. So this file will contain all the trained variables and all the parameters that are required for scoring. So the JavaScript handles the backend logic. We have three helper functions that is used to extract the or transport the inputs from the app to the model and get the scored result back to the app. These are done using three helper functions in Java. And then this app is definitely going to be very useful for insurance companies like Prudential, where the underwriters can easily check the classification or the group that a prospect belongs to, and can take quick decisions without having to go through extensive the cloud-based deployment that is the general practice in enterprise level predictive model deployments. So that is the main purpose of the app. So these are the two things that I worked on in the project, that is to build models, to be able to propose a model for scoring, and to come up with a suggestion on how we can use the predictive model to explain the adversarial actions that we are going to take, along with the an experimental Android app development. This is the Android Studio, and this is the design of the app. We have 9 predictors, and we have checkboxes, and when the user clicks on predict class, the class should be displayed at the bottom. So the design, and this is the text, the XML text, and the main activity.java has the Java helper functions. There are 3 of them, which does the job as explained in the previous slides. So once the design is done, one would run the app to launch the actual app, and I don't have an actual phone connected. Instead, I have created a virtual device, which is a Nexus 5X API 28. So I'm going to install this app virtually on that device. In a few seconds, it should come up with the phone. This is which is this. So if I were to have the actual hardware, that is my phone connected, the app gets installed on the phone. Thank you.
In conclusion, the problem that Pathwise Analytics was trying to solve was that the underwriting process at Prudential was extremely labor intensive, and that involved a lot of human input. It was lengthy, and that took 30 days or more to issue a policy, and it was complex because there was large volumes of data that was constantly changing. To solve this problem, Pathwise Analytics created a risk mortality tool that was designed to emulate the decision-making capabilities of a human underwriter. We also created a mobile app for underwriters, agents, and customers to calculate real-time risk, and also for leaders, a dashboard for performance monitoring and decision support. The benefits of this were multifold. First of all, There was much faster customer service by using the risk mortality tool. The underwriting process took from 30 days to 5 days. Operational efficiency also increased about 15% per year, and cost savings of $6 million in total for Prudential. So how did Pathwise Analytics do this? Well, it took us 8 weeks from planning to closure to first design our methodology, 2, gather and analyze the data, 3, create the model, 4, validate the model, 5, select the model, and then create the mobile app and presentations for the end users. Like I said, it took about 8 weeks, and the whole time we were able to provide on-time status reports and deliverables. Our on-budget cost was also approximately $200,000, which was quoted at the beginning of this engagement. Also, Prudential will have an estimated ongoing model maintenance fee of $20,000 per year. Because Pathwise Analytics has worked with clients on similar projects in the past, we recommend specific implementation success factors that we think are important for Prudential. 1, make sure there's clear ownership and commitment from leaders across the company. 2, focus on prioritized changes. Prudential has a lot of actions I can take moving forward, starting from the risk mortality tool to creating the mobile app to creating a Tableau dashboard. Don't try to implement all these changes at once. Focus on one step at a time, depending on what the business prioritizes. 3, gather the sufficient resources to execute these recommended changes, including a firm budget and personnel. 4, create accountability for specific actions during the implementation process. 5, develop continuous improvement plans for the model, including ongoing maintenance, a long-term vision, and again, long-term sustainability. We don't want this to be a one-time solution for Prudential. We want it to matter far down the road. And lastly, you want to implement effective program management and change management center across the company. There are a lot of changes that Pathwise Analytics is suggesting in this engagement, and we know that success will hinder on successful program managers and change managers who will have the best interests of the company at heart.